This is Kalol here. Let me quickly start by sharing my screen. Okay, there we go. Let's have a recap from yesterday. Yesterday, we learned about basically about SSH, secure shell. That is how you connect to your remote Linux system, or rather your remote computer. Okay. So today, we will dig a little bit deeper and start learning about Linux operating system basics. So the first thing that I would like to tell you is what we are learning here is about Linux. So now it is pretty easy to get confused because there are so many varieties of Linux. Okay, so this is the basic Linux icon that you will always find. It's loading. It's taking some time. Yeah, there you go. Okay, but then Linux is a open source and free to use operating system, unlike Windows or Mac. These operating systems, Windows and Mac, are proprietary. That means they are owned by private corporations. Unlike that, Linux is actually open source and it is free to use. And even you can create your own Linux distribution to suit your requirements. Now, where the confusion comes up is like you have to first of all realize that the word Unix will also come up a lot. Okay, but Unix is not equal to Linux. Why so? Because Unix was developed somewhere around the year 1970. And then all through that time till now, it is still being developed. The problem with Unix was it was not free. Okay, it was a proprietary operating system. And the modern day Linux that we have today, it is a different operating system, but the code base for developing the Linux operating system has been taken from Unix. Okay, and it is not only Linux, actually even okay, let me actually give the year first. Linux was developed somewhere around 1990s. Okay, the primary, the main person who did this was somebody called Linus Torvalds. This guy made it free. So he's actually a very important person in terms of, so it's actually this guy. Let me quickly paste his image. Because of him, you can say we have got, we are using Linux in its so many forms. Now, these are things, bits and pieces that you should know, because it's not that it will affect your learning, but you should definitely know these things. So, because Linux and Unix, they are the names are often used interchangeably, but they are not the same thing. Linux has derived from Unix, but it has got its own, the philosophy that it has inherited is from Unix. The operating system structure, the file structure, we will learn those things in a short while. So, but it has derived it from Unix. Okay, and so it is something like this. If you talk about operating systems, there are three main operating systems in the world right now: Windows, Linux, and Mac. These are the three families of operating systems. Windows, we commonly use Windows. That is the most used operating system only in personal computers, in your home computers, in your local laptops, or in your office PCs. It is popular so much because that's the way actually Microsoft has managed to market it. So 99% of the times when you purchase computers from anywhere, be it a shop or be it online, wherever you buy it from, you already have the operating system pre-installed. Okay, but that's why it has become so popular. And apart from that, it is also graphical user interface based. So most of the times you would be using your mouse. The keyboard usage will be much lesser in Windows. But when you enter the tech world in IT, you will have to rely on Linux. 70% or more of the websites, if you consider the entire internet, their servers, hosting servers, the middlewares, wherever from wherever the websites or web applications are being hosted and controlled and managed, they are all Linux based. So these operating systems, they are so how are they different? They are different on based on the concept of something called kernel. Okay, there is something called kernel that is what defines every operating system. So in Windows, you have got the Windows kernel. Okay, in modern day, they are reverting to something called modern day Windows. They are using something called PowerShell. Linux, you have got something called, its name is Linux. The name of the kernel is also Linux. In Mac is also, you will have a lot of similarities between Mac and Linux, but they are not the same thing, obviously. Mac is also a proprietary operating system, unlike Linux. Linux is the only one which is free here. Windows and Mac are proprietary. That means you, without Windows or Mac, Microsoft's or Apple's explicit permission, you cannot alter their source code. Legally, you are not permitted to. If you want to customize your operating system for your own use, you assuming you have the technical capability for that, they would not allow that. But unlike that, in Linux, you are free to do that. Okay, so the kind of license agreement which is there in Linux, like this guy made it completely free. And there is a consequence for that also. In Mac, the kernel that is used is called Darwin. Okay, so I'm trying to give you a real-time picture here. Now, you might think of, like, then what about iPhone? You have got iOS in that. What about Android? That is also operating system. Yes, operating systems are made as per the hardware on which they are installed. So smartphones are a completely different kind of hardware. Although with every day with more innovations and I mean, like with the pace at which technology is advancing, the power of a, like the line is blurring between the capability of a laptop and a smartphone. Okay, in many features, smartphones are way more powerful than even the best gaming laptops or business laptops. Nevertheless, if you compare it from like in terms of hardware, both are computers. A laptop is also a computer, a desktop is also a computer, and a smartphone is also a computer. Whatever that smartphone may be, it may be iPhone, it may be a BlackBerry, it may be a Google Pixel, or just plain from any other brand that you are buying. So don't mistake the name of the brand here. Here I'm talking about the operating system. So the way it works is, if you have, let's talk about Android, for example. So Android is actually also Linux based. It is just a modified version of Linux. Similarly, iOS is also Darwin based. Okay, it's just that these are separate operating systems, but at the base, they will have the Linux family of operating system, all Android phones. Similarly, all iOS phones, they will have the Darwin kernel. Okay, so this is the name of the kernel that I was specifying. It is based on the kernel that your operating system is identified. But basically, we have these three families. Okay, apart from that, I mean, like if you are into electronics, you would know then there is something called Raspberry Pi. Usually it is used in drones. And to give you an example of how powerful Linux is and how customizable it is, let me show you. You must have heard about Tesla. Okay, so this is it's an electronic vehicle, EV. Elon Musk and all that, you must know it already. So this is your typical Tesla electric vehicle, electric car. Okay. And then there is you might know about this one also. So this is the Mars rover. Right now, there are many rovers that NASA has sent, but like this is one of the rovers. So currently this is on Mars, millions of kilometers away on a different planet. So what has this got to do with Linux? In both the cases, actually, because Linux is free, Tesla has developed its own Linux operating system to operate with the computer of the car. And similarly, the NASA guys, when they sent the rover, they also have got a very simplified Linux, which they use on the Mars rover. So both of them are using Linux. And then you have got, you must have seen like drones are pretty common, be it the military ones or the normal ones, like these kind of drones. So they also have customized Linux operating systems, and their hardware is a little bit different, as I was talking about. This is just to give you an idea, okay? We are not getting into all of this, but you should know, like they use something called these drones and these kind of equipment. They actually use a separate hardware, something like this. This is a Raspberry Pi. It's a very small module, 3 to 4 inches in size, smaller than your, I mean, like the size of your credit card or debit card. Okay, it has got its own, but it is purely hardware, and using your main PC or Mac or whatever you want, using that you can actually write the commands so that you can operate these systems. So basically, every time where the thing common here is you will always have a computer. So the structure goes something like this. Let me draw the pyramid here. So first of all, you have the hardware. That hardware will be your things like CPU, RAM, hard disk, or let me just call it, no, let me call it hard disk only, and networking. So when I say networking, some kind of wireless adapter inbuilt. I mean, like you cannot see it usually in your laptop, but there is a wireless card, or else you will have a Ethernet port. Modern day, I mean, like the slimmer the computer, like in your Android phone and all that, they all have wireless receivers. Okay. So when we talk about hardware, it is this stuff. Now, the way it works is on top of the hardware, the next thing that you will require is that sits on top of the hardware. Okay. What is it? The next thing that you need is the operating system. And this is this operating system, it includes its own source code. Like that would be millions and millions of lines of code. And in that also, there is something which is called the kernel. So kernel is the first part of the software that gets loaded when you start your when you start any computer. Okay, when I say any computer, that can be this drone, this rover, this Tesla car, or your PC or your smartphone. All of them are computers because all of them have these things in common. They have got each one of them has got a CPU, RAM, hard disk, and networking. And apart from that, there are multiple other peripherals. But these are the basic things that would definitely be required. Okay, so whenever you are starting your computer, the first thing when your operating system loads is it is the kernel which actually gets loaded. Okay, so on top of the hardware, you have your operating system. Okay, and then on top of the operating system, then you have your applications. Okay, for example, Chrome, your browser, your email, like Outlook, like I'm right now, I'm using this OneNote, or whatever you can think of. Like if you are playing maybe you're playing Call of Duty on your Android phone, or maybe you are using WhatsApp on your iOS phone. Okay, iPhone. So those are applications. Applications are installed on top of the operating system. Okay, without the operating system, applications cannot be installed. This is the basic hierarchy. This is the bottom up, you can say, hierarchy that is always followed. Okay, so you cannot, if you have got no operating system in your computer, you cannot install an app. That is just not possible. So keep this in mind. This same thing, same philosophy will be replicated while using our Linux systems also. Okay, there will be the hardware. So if you think about it, when we now try to join the dots here, when we launched the EC2 instance in earlier class, so let me quickly open it up. So anyone has any questions till this part? I know it might sound a little bit daunting, but believe me, it is very interesting once you start learning this, because these core concepts will later on help you understand how things are working in the background. And why do you need to know these things? So that you can troubleshoot. You can easily identify the problem. Okay, so I'm getting an SDK error because I have to relog in. Obviously, this is on a virtual machine. So I'll do the IAM login and I will need the MFA code. Okay, I think it has remembered my login. Let it load. So this operating system that, so if I check this is when I launched this AMI. During that time, I had the option to choose multiple. It basically it's hardware. Okay, so that is when if you see the type of system it is, somewhere it should say T2 micro, maybe in the where it stopped, IP address. Yeah, so instance type is T2 micro. Okay, so if I actually open EC2 in a different tab and try to click on launch, why is it opening with global view? Nope, I don't need this. I want instances. So if I click on launch instances, you will be given that option to basically choose your hardware, where you can configure what kind of hardware do you want to use. Okay, so I'm actually not going to create the instance here. So yeah, so here when you are choosing, hang on a second, let it load first. So in this part, when you are choosing the AMI, you are choosing the operating system. But operating system, as we have seen, it comes after the hardware. So first of all, here when you are choosing your hardware, this instance type section, this is actually, if you click on compare instance types, you will see a list of all the instance types that are available. So here you can choose. So these are radio buttons. So any one of them you can choose. So in real world, these T2 micro, T2 nano, T2 small, they are not used in the real world at all. Okay. These are only for testing and maybe learning or training purposes. Do not ever say in your interview that you have used a T2 micro or a T2 nano, T2 small on real-time projects. No, that is solely meant for testing or maybe learning, nothing else. Okay. Real-time servers cannot handle this. Now, why are we using it? Because these are free tier eligible. And for the purpose of our learning, they are good enough for us. Okay. We don't need to bother about like the performance and all that. Because any website and all that we are going to create, deploy, they will not be used by 100,000 customers. Okay. I don't have to configure it in such a way. The purpose here is to learn the internal workings here. So if you want to learn driving, you don't have to start with a Mercedes. Okay, you can very well use a second-hand car, a very cheap one. It should have the basic parts of a car. That's all. So it is something like this here. In real-time scenarios, if you see here, so if you compare, what are the main things you need? CPU, RAM, hard disk. So this is also called, I will come to this later on. RAM and hard disk both are referred to as storage. But RAM, hard disk, networking. So think about it like this. These are the four things. So here, if you see in this instance type, the storage part you will not get to choose because that you will get separately. But if you compare, first of all, that architecture thing, that architecture is nothing but it is referring to who is the hardware manufacturer. Okay. So anything with this i386, x86, 64, these are all Intel based. So Intel is another hardware company. Okay. I'm talking about this. So I just search for Intel and then images. So this is the company I'm talking about. Most of our computers have that. So whatever processor they have, like iCore, Itanium, Xeon, whatever they use. Okay, but the hardware supplier is Intel. Okay, that is where your architecture gets defined. x86, 64. So 64 and 32, they are bits. Okay. The other one commonly used is ARM. So ARM is again a different company. Like Intel, you also have ARM. So ARM is another semiconductor company. Okay, they also make chips. Okay, oh, okay, not exactly ARM. I don't know. Google is confusing me with. So this is another company, and the hardware actually defines what kind of software will be installed. The hardware comes first. So while choosing your instance type, you can choose. Okay, so for example, if you take a A1 4X large, this will mean that you have got 16 core computers, 16 processors. And it is ARM 64 based, 64-bit and ARM chipset based. And it has got a memory of 32 GB RAM. And it has a network speed of up to 10 gigabits. Okay, so these are the kind of servers that you will require in real time. Again, that depends on your requirement, use case, how many users are going to hit the server with web requests, things like that. Okay, so if I cancel this, I hope this gives you an idea. Actually, I can just get it. The other part is the storage. So 3 things I showed here. That was the CPU, the RAM, and the network. And the storage is something that you can choose here. It comes up as a separate module. Okay, you can. So right now, I mean, like by default, it is coming up with 8 GB. Or like if you use T2 micro, then it will be 10. It depends on the operating system. Like, but 10 GB is 8 GB is the minimum, and for Amazon Linux 2. And if you use Red Hat, that is another distribution of Linux. So that will take around 10 GB minimum. And you have got in as free tier, as you can see, up to 30 GB per month is free. Anything that crosses 30 GB will be chargeable. So this is where you can define the kind of storage for hard disk that you want to choose. Okay, so again, getting back, this is the structure that we will have to follow. Okay, so the hardware comes first. On top of that, the operating system, and what kind of kernel the operating system has defines the OS family. So there are 3 kinds of kernels that you can have, like Windows, Linux, or Darwin. Linux means it's a Linux operating system. Windows has its got own Windows PowerShell or Windows kernel, and Mac has got something called Darwin. Okay, so whatever device you might be running, if it has got a computer, then it will definitely follow this process here, this architecture. The hardware first, on top of that operating system, OS, and on top of the OS, then any of the apps that are then installed. So this is rather more of a common idea, a common knowledge that you should have for any working computer. Now let us come to the first thing, like that I started with, Linux. So what about Linux? In Linux, so when you say Linux, that is actually a very vague term, because Linux is a collection of, when you say Linux, it does not specify which exact operating system are you using. For example, in my case here, the EC2 instance that is running. Okay, so let me get rid of this. So the instance that is running here, it has actually used something called Amazon Linux 2. Okay, this is the, so AWS is providing us with all of that. We don't need to have our own, like our own operating system ISO files. Okay, they are providing that for us. That is the reason why we are using AWS. Similarly, other cloud providers will also provide you with the operating systems. If you want something customized, you can create your own operating systems, customized operating systems. Okay, we will cross that bridge when it comes. So this one is now Amazon Linux 2, but this is a specific operating system that is in use. But if you say Linux, that does not give a complete information, like which exact Linux operating system are you using. That is what is called, you can term it something like Linux, that is called distro. Okay. So this is short for a Linux distribution. Okay, the word is lengthy and sort of sounds fancy, but what it basically means is a kind of Linux that you are using. So there are various distributions of Linux. So let me expand this picture here. These are some of the various versions of Linux. You might use Red Hat, Memphis, Turbo Linux, all these names that you are seeing. So originally they were derived from this Linux created by this gentleman. Okay, he was not alone, but he was the primary driver, Linus Torvalds. Okay, and then using this base code, CentOS, Ubuntu, the most popular ones are like commercially used is something called Red Hat. Then SUSE Linux is very common. Mint is very common. Ubuntu is the most popularly used in the, just like Windows is the most popular operating system globally used. Similarly, in the Linux community, people who don't want to get into much technical things, they use Ubuntu GUI version. All of them have, most of them have graphical user interface version also. But having said that, any version of Linux you work with, sooner or later, you will have to come to this. By this, I mean the command line interface. Actually, I have not logged in. So let me log in. Okay, do a SSH. Let me quickly grab the public IP. Oh, sorry, I did not even start this. I forgot to start. Anyways, so as you can see, okay, successfully started so soon. Or maybe the page did not refresh, updated there. So I have an IP address. So if I have an IP address, I should be able to log in. Specify username. By default, in this case, it is EC2-user. If it would have been a Ubuntu operating system, then the username would have been Ubuntu. Again, a different distribution of Linux. I choose my key, click on OK. And there you go. I'm logged in to my remote server. Okay. So let me fire up the keyboard here. So if you press, so initially when it launches, as you can see, there's a lot of stuff here. Okay, you might not want to see this. So very simple. So either you can type clear or you can simply press Ctrl and L, and that will clear the screen. Okay, so you have to learn lots of keyboard shortcuts, but then that will come up with practice. Okay, that is something very common. And so sooner or later, any version of Linux you use, you will have to encounter this page. That is called terminal. Okay, so if there is no point running from it, and this is going to be, and as DevOps engineers, you definitely need to learn Linux, whatever cloud infrastructure you are using, does not matter. So any questions till this part before I start getting into operating system details? Cool. So let me add a page. So before you get into Linux, you should actually know what I taught till now was relevant for all operating systems. Okay, that is something that you should know irrespective of Linux or Mac OS or Windows, does not matter. Now what I'm going to discuss is Linux directory structure. So directory and folder, what the term that you use in Windows is called folder. In Linux, it is called directory. But they essentially are the same thing. So now you are able to connect to your server, and this is the kind of interface that you are going to see. This kind of interface where you are solely dealing with commands, that is called a command line interface. Unlike that, this is a graphical user interface. Okay. Most of the times in servers, you will not have graphical user interface. Why? Because servers are meant for specific, they have got very specified tasks. Maybe you have got an email client server. The entire purpose of that server is to just send and receive emails, check if the firewalls related to emails are open or not, and authenticate users. So basically email sending and receiving. So because they have such specified tasks, other regular tasks would not be performed in those servers. So there it is. The problem with GUI is, if you see, this is a Windows GUI environment. So if I check my task manager here, and if you see the processes, just to keep this entire operating system working, there are so many processes which are working in the background just to support one user. Okay, just to support one user. This user is only using these many right now, these many processes and applications. But just to keep this thing alive, there are so many other processes that the system is using or working with in the background. Okay, and and there are so many other services also. Now, if you have a graphical user interface, this will be very bloated, and this is going to be very heavy, unnecessarily heavy, which you do not require in a server in real time. That is why servers usually, they will also have an operating system. Like this is a completely a command line based operating system here. You don't have any graphical user interface. Okay, so let us understand the directory structure here now. But this is what you have to start learning. Like get used to command line interface versus graphical user interface. Okay. Let's see. I will try to compare and show it to you. Oops. So, for example, you are seeing the directory structure here in the Windows operating system. It does not matter. Every operating system has got files and folders, so they will have some directory structure. So, if you compare Windows versus Linux, in a Linux machine, there can be only one root user. Okay, but in Windows, this is one major difference. Later on, if and when you learn Azure Cloud, you will realize this thing. In Windows operating systems, you can have more than one root user. And they are actually identified by the drive. So right now, there is only one single hard disk installed here, but you can have multiple hard disks in any computer. So even if you have multiple hard disks in a Linux system, there will still be one single root user. But if I add another hard disk here, just imagine this. I can't do that right now. So that would automatically get a different drive name. So this is C drive. It is called drive in Windows. D drive is for the CD-ROM and DVD-ROM. And then automatically, if I add another hard disk, it will become CDE, E drive. So each of these drives can be treated as a root user for their own functions. Okay. But compared to that, in Linux, you will not. So if I get into this C drive now, it has got these files and folders. Okay. Many of them are also hidden. Later on, we will see like there should also be hidden items like this $win, 𝐸agent, program data. These are hidden. That means the system is avoiding exposing them to the regular users. Okay, now why I am able to open this here? Because I installed this operating system. So by default, I am the admin. Okay, so but if you compare it with Linux, Linux is more security based. You have been logged in by default as EC2 user. So EC2 user is not root user. If you want to become root, then you will have to do sudo su -. This is the command for switching to root. So as you can see now, earlier it was EC2 user. Now it is root. Okay. And that's why this $sign has changed to a £sign. That means now I have got 100%. So I literally have got level access over this system right now. Okay. So to log out, shortcut is Control-D. So when I logged out, it actually logged me out of the root user. Now if I press, so see, it automatically typed logout. Now if I do logout once again, can anybody tell me what is going to happen? If I do Control-D, any guess? Actually, it happened there already. I thought I will press enter, but so it logged me out of EC2 user, and that was the last remaining user in the instance. So that is why I have been kicked out of the complete system. So I'm back to my Windows system here now. Okay. So what I can do is I can just press, somehow you have to press capital R, okay, to relog in. Shift R, and there you, I'm logged in back. Okay, but again, I'm logged in as a EC2 user. So Control L. Now getting back to the folder structure. So in the GUI environment, as you can see, like if this is the thing here, then if I go into Windows, then Windows will have its own further folders. Now, if I get into any one of these folders, then it will have their own file. So this is a file. Okay, so a file and a folder are different concepts in are two different object types in Windows. But compared to that, in Linux, although you can call it a directory, which is containing other files, but in Linux, everything is a file. A shortcut is a file, a device is a file, a directory is a file, and a regular file is also a file. Okay. So basically, the major difference between Windows and Linux is like every file will have its extension that defines the type of the file. If you right click on it and click on properties, you will see the application extension. So in this case, this is a .dll file. Similarly, if you have a maybe a sound audio file like .mp3, a video file will be like .mp4, a Word file will be like .docx, an Excel file will be .xlsx, a database file will be .db, things like that. Windows identifies objects with the extension, but compared to that, Linux does not care about the extension at all. Even if you do not give it any extension, everything is a file in Linux. Now, why you need to know about the directory structure is I can directly start getting into Linux commands, but commands. Okay, so let me actually write this down. There are three things. Why you should know the directory layout is because understanding the directory structure will help you in future when you are searching for certain files or components on the system. So you will come across questions like these whenever you are trying to use the command line interface. For example, like where are my programs installed? Okay, you will need to know the path. We will come across this pretty soon. Because you don't have any graphical user interface, it is actually, if you do not know the structure, it will be very difficult for you to navigate. So where are the configuration files? Or in short, config files. You will need to know this because you will need to alter these files to change the behavior of the software. Then where are the log files? You run across errors. On seeing the log files, you will be able to identify what do you need to change, what do you need to rectify. Okay, so that is the reason why you need to know about the directory structure. So having said that, it would be a lot easier if you can see it visually. Just like you have it in Windows, like when you're clicking and then you can see. So this is the path. Okay, C drive Windows branding and then shellbird or something like that. Okay, so you need to, but in command line interface, whenever you come across this, all you can do is you can type pwd to check the path. So right now, this is the directory I am in, EC2-user, it is a directory, and this is the path, pwd, present working directory. Okay, so let us know about a few common directories, which are sort of, now, depending on the Linux distribution that you are using, okay, it will vary. So these are all different Linux operating systems, all these icons that you are seeing. So depending on the Linux distribution, your folder structure will be a little bit different, because although at heart they all have the Linux kernel, but they are all customized for their own use. But nevertheless, there are certain files and directories that would still be there. Okay. So, for example, now, before I proceed any further, you should keep in mind this thing. I will be uttering the word root multiple times. But then you have to be clear. Root is a common word. Okay. So in Linux, root can be used as a symbol like this backslash. Okay. So when I am using this, I'm actually referring to this icon, this one, this keyboard icon. Okay. This backslash. Or I can be using the word, literally the word root. These two are different things. Both are pronounced as root. What is the difference? This one is a directory, or you can say folder. But this one, when I literally use the word root, it is actually a user with super admin access. Okay, this is actually a user. They are two different concepts, two different things. They are not the same thing. Even comparing them does not make sense. It is like comparing apples and oranges. So let me show you what I mean practically. So when I do sudo su hyphen, I will be logged in as the root user. So this root is actually the user. By default, two users will be present in any AWS instance that you create, Linux instance. One will be the root user and the other one will be the EC2 user. So now I'm logged in as a root user. Okay. But if I check PWD, whenever you are doing PWD, you will always get a path. And it will always start with this slash in the beginning. Okay. So whenever I'm speaking in terms of path, it is the context that matters. What is the context? That will define the usage of the word. So whenever I'm dealing with path and I'm saying root, I'm actually referring to this folder, root. Everything in Linux starts from this root folder. Okay. Just for example, like if you do a comparison in Windows, everything starts with the C drive. So this C drive, you can compare it equal to the root directory, not the root user. Okay. And if you think in terms of like user, then if I click on this thing here, start icon, as you can see, and then if I go here, so the user is admin1. Similarly, analogically, if you see in the Linux world, this is my root directory. Everything is installed in this. It starts with this. Every path will always start with this. But then the word root is actually the name of the user. These two are different things. Keep that in mind. So basically how you will pronounce this is root. But the first root refers to the directory and the second word root refers to the user, as in the root user. How can you know which user you are using? So for that, the command is who am I? Just type that and you will see. So right now I'm logged in as the root user. Okay. So if I press Ctrl D and log out, now again, if I type who am I and press enter, now I'm logged in as EC2 user. Make sense? So now let's get back to, so this is something you should definitely know the difference. Now let us get back to the folder structure. The most common ones are like definitely root. So this is your root. So this root I'm writing, this is not in terms of user. So this is the root directory. This is the starting directory. Always it will be so. Okay. And then there are other files, directories. For example, so let us learn how to navigate that. So let me clear the screen here, make it a little bit larger. Now to show you the structure visually, I need to install a particular software that is called tree. Otherwise, what will happen is, if I just, so let me actually install this. I will explain these later on. The way you install is like this. Yum is the command, and then the attribute, what you want to do with the yum command. A single command in command line interface can do multiple things. So you want to use the yum command to particularly install a software. The software is called tree. Now it will connect to the internet, and it has found the software from its database that is called the repository. Okay, so it is checking this repository, and for Amazon version Linux 2, in the repository 2 is called Amazon 2 core. From there, it can fetch it. Now it has stopped because it is asking me, do I want to install it or not? Because it is telling me that it will download 47 kilobytes, and then after installation, it will be 83 kilobytes. Okay, so it is giving me a time to check if I have got sufficient size available on my disk or not. So I'll just type Y for yes and press enter. Now it is installing this software. Now why I installed this thing is, you will see, so that I can show you the visual directory structure. Okay. So how it works is like this. Let me just type tree command here and press enter. So there is nothing present in the root directory. Okay, so let me go one level up. CD ... will take you one directory up. So in terms of Windows, so for example, I'm in this. So this is my path right now. So let me get into some path. Let me get inside Windows, and then let me get into a random folder like this. So this is my, in GUI, I cannot enlarge this any further. Okay, so maybe you will have to come a bit closer to the screen. This is the path. C Windows and then the name of the drive. Okay, so if I click on this, you are going one directory up. So that means right now you are in the, what is the name here? BCST DVR. That is the name of the folder. So if I click this, I will go back to the Windows directory. Okay, so this is called one level up. You went one level up in the directory structure. So similarly, if you type CD stands for change directory. If you type after that ... this means you are moving one level up. Okay, so right now, if you see my PWD, this is my directory structure. There is the root directory, and inside that there is another folder called root. So if I do CD ... I will move one level up. That means I will go from the root folder. I will go to the actual root directory. I mean, like both of them are root in pronunciation, but they are different. Okay, they are two separate folders. So now, as you can see, this icon has changed. Whatever is present here, that will always show your present working directory where you are. So if I do a tree command here, so all the thousands and thousands of files and folders, they are all showing up. Okay, so this is actually too much. So it has given you that entire structure. So let me make it a little bit. Let me take up something smaller here. So let me first of all log out, and Control D to log out of root, Control L to clear the screen. Now, who am I? I am EC2 user. Okay. So if I check my PWD now, it is root home EC2 user. So let me move one directory up. So now I'm in the home directory. Okay. So I have moved up one directory from EC2 user. I have gone to, so from EC2 user directory, I've gone to the home directory now. Okay. So if I do a tree command here now, it will show me. This is how it looks like. Okay. One directory is present. So a single dot means your parent directory. I will come to that later on. Okay. Now that is why I installed the tree command so that you can see. Now let me quickly write down a few names. Tomorrow we will get into these details further. So few more directories that will be involved are root bin, root etc, root home, root opt, root tmp, root user. So user is not USER, it is USR. Root var. These are the few of the important ones which are always common in all the different Linux distributions. Okay, so these are the major ones that you should know about. And root bin contains the binaries. Binaries are programs or executables which are understood directly by the computer hardware. Okay, because they will not understand our language. Any computer that you deal with, if you want to give it any instruction, somewhere down the line, it should be in a binary format. It has to be converted. Later on, we will see that is called compiling. Okay, we will come across that later on. And then there is the etc. etc stands for etc. Originally, when Unix was developed during the 1970s, so during that time, they created this, the developers then created this etc folder, etc folder, where they used to always dump everything which they thought was at that point of time, which might be important later on, but right now they don't need it. So it was a common dumping ground. But later on, as Linux evolved, now etc is actually a very important folder where all the system configuration files are present. Root home will be your home directory for all the regular users apart from root user. Okay, so this is one important thing you should know. The home directory, whenever you are using the tilde symbol, whenever you see the tilde symbol, that means for that user, you are in its home directory. Okay, so whenever you want to go to the user's home directory, all you need to do is type cd and press enter, nothing else. So you will come up whenever you are seeing this tilde. This tilde means I'm talking about this particular symbol here, this one. Okay, so this one specifically, that wavy kind of thing. You have to start learning the keyboard icons. These are not icons that you regularly use, but in Linux world, you will be using them. So whenever for any user, if you see the tilde symbol here, that means you are in that user's home directory. Every user will always have a home directory. Okay, so that is their starting point in the directory structure. So if I do a PWD for EC2 user, see the difference. For EC2 user, it is root home / EC2 - user. So everything that the EC2 user will be doing will be inside this folder that is also coincidentally named as EC2 user. But if I log into root user, sudo su-, so again, there is a tilde symbol here, but this tilde is not the same path as this one. So who is the user here? The root is the user, name of the user. So if I check a PWD here, so see the difference here. Okay, what I'll do is this is something you should definitely be aware of. So whenever you are logged in as EC2 user, your home directory will be root home / EC2 user. But whenever you are logged in as the root user, your home directory will be root. Root user is the only user in the Linux system who has got a different home directory from any other user. Okay, so on that note, I will have to wrap up the class today. Okay, I did not observe, but there have been some chat messages.
Thank you, Kalol. Before we end this class,
No,
I would like to know.
let them, Emmanuel, let them ask any questions if they have any doubt. So let's just give it 5 minutes. Any queries related to whatever I have taught till now? So Guru Raj is asking, do I get course completion hard copy? What do you exactly mean by that, Guru Raj? You might want to unmute yourself now and ask it. Like, are you asking for a completion certificate or like the day-to-day files and folders that I use? You will get both once you enroll. I mean, like, in the short answer is you will get both. Any portal where I can log in and check all the recordings. Okay, so that portal is going to be your Google Classroom. And what else? Please share the course content that has been shared. Okay, so yeah, Emmanuel, but I don't see anybody's asking any questions. So yeah, please continue.
I have posted a link there, a payment link to enroll into this course. Tomorrow is a last day to get the discounted offer. So please don't wait for tomorrow. If you want to go ahead and complete this course with Kalol, go ahead and enroll today.
Okay, Manam Parvez is asking, is there any plan? Of course, there is a glide path. We will share that with you shortly. Day-to-day basis, it's an incremental plan. So right now, I mean, like tomorrow also we are going to learn. Just for tomorrow, I can tell you, we are going to learn. I mean, like it will continue with Linux basics. But having said that, there is a course link. Just give me a second. I'll have to fetch that. I actually forgot to show that. You might want to, Emmanuel, if you can post that link in the WhatsApp group also. And let me show you the course contents. I mean, like that will give you an idea about the plan thing. Actually fetching that link. 1 minute, please. Okay, I got the link. So you can go to this link, check your WhatsApp group. You will have it here. Check this link. It's a short URL.
I have posted that in the chat group itself of Zoom.
Zoom thing will not be available right after the class. So maybe you want to post it in
They can click right now. They can click right now and open it. And I think they can also download.
I'm actually trying to open it on my screen here. I'm also checking if the link is working or not. Yeah, it's a Google Drive thing.
Yeah, I asked one more question, like where will I get the all previous recordings and future recordings?
Previous recordings as in Google Classroom. And when you say previous recording, the course has started only this week, since last Monday. So this is the 4th day of the class. But yeah, as Emmanuel responded, like it is going to be in the Google Classroom. So this is your course curriculum, like Manam asked this question. So this is your course curriculum. These are the this is the glide path in order that you are going to learn. Please check this link. These are the, I mean, like I've given you the major softwares for each part, each module. They are broken up into modules and step by step. And finally, this is something that you should definitely accomplish. That is the capstone project. Okay, where all these tools will come work integrated together.
So this will get completed within next 30 days, huh?
Yes.
So I have one more question, like do we get any kind of hard copy of course completion certificate?
We do email it to you, so you can take a printout in case if you need a hard copy.
Okay.
Yeah, when you say hard copy, I mean like that printed certificate is like, again, that is like mailing and that is postal mail, right? You can easily get a printout. And even when you are sharing like with any of your employers, then also you can share that soft copy. That should suffice.
Okay.
Yeah, any other question? Or else I'll wrap up the session. Please go through this link. This has got further details here. So what you are learning right now are the prerequisite concepts, okay? Because you definitely need to know about Linux. Without that, it is not going to work out at all. So that is why, I mean, like the base course I have not yet started.
See, this Jenkins installation and all, do we do it on local system or everything in AWS only?
No, AWS. AWS. In local, you are only going to install Git Bash and VS Code. VS
Okay.
Code is like a integrated development environment. Okay. It is not mandatory because anyways you will need to install Git on your system. But see, your local system also needs to interact, right? See, right now, for example, this MobaXterm software is interacting. This is the software that I'm using to interact with the remote system. So in that sense, yes, very few things you will need to install locally.
Okay. So Jenkins, I was just thinking about Jenkins. Jenkins, are we going to install and configuring local
Jenkins,
system?
no. That will be in the remote system. But you will be able to access it via browser on your local system. Because Jenkins is sort of GUI based. It works through the browser. And okay, something related to module 1, explain module 2. So actually there is a glide path for this, Manam. I mean, like I will have to explain it. I mean, like this will come up in the next week or so. But here there is a architecture diagram which I'll have to use. But very briefly, how you are going to install Jenkins, install Git, use GitHub, install Maven, and then integrate all of them together. So these are the basic steps. Setting up Jenkins server, running Jenkins jobs, integration. Before all of this, obviously, there is installation, okay? Without installation, nothing will work. And then running the job to pull code from GitHub. You're going to write code in GitHub. You're going to fork code. I will share that code repository with you. And then you're going to integrate. So you have to install something called application server. That is called, the one that we are going to use is Apache Maven. And then we are going to learn to integrate it with Jenkins. And then obviously troubleshooting, because you will come across build failures. So here the major project will be to build a Java project completely using Jenkins. What the word build means, that requires its own class and session. And then initially we will be doing this thing manually. All of these things. So in every step by step, whatever we are doing, you can consider them as mini projects. Okay. But then at the end, for each module, major part will be to obviously integrate all of them so that they are automated. 1 hour will be very short time for module 2. Okay. So, or module 1. Okay. So see, I think you are, Manam, if you would be kind enough to unmute, let me explain it to you. You're misunderstanding here. Module 1
Sorry,
or module 2?
my kids is like reading behind me, so that's why. Yeah, so I just want to know that like, in 1 hour, are you going to cover like entire module 1?
That is not possible, Manam. Complete all of this
That's
in
I was
1
thinking
hour.
too.
I can do it. I can do it in 10 to 15 minutes. But then where is the explanation? I will need to explain it to you. You guys are students now. That is module. So if you think of it like that, then there are 7 or 8 modules in total. So this is not a 7-hour course, right? That is not possible.
True.
Okay, so it will every day. I will have to give time for you guys to absorb, right? It will. So this will be distributed over multiple hours. Every day we will. I mean, like I can't hardline it because there can be questions people will ask, and then I'll have to answer them, and there will be troubleshooting on your systems, like we did. I think it was on your system with Putty and some key or something, if I remember correctly. So
Yeah,
no, it
but
is not 1 hour for each module.
but will you be like the flexible, like if let's say today it take a little bit long time because some of our student or some of us had a problem, so you help us to fix it and it get delayed to next week or next day. So is it okay or just hard
Next
stop?
week?
I mean, sorry, one day or 2 days.
Yeah, I mean, like if you then unnecessarily you are, this is instructor-led training, so I will have to follow the time decorum here. It's just not my time, it is other people's time also. They are also working. So now, I mean, like in case there is some technical glitch, I mean, like which we cannot postpone. So yeah, there I will definitely be flexible. And you will also be part of one of the DevOps tools for collaboration and communication is something called Slack. You will have access to our Slack channel also once you become a paid member. And then there you can post your screenshots with error logs, and then as and when, maybe not immediately, but I will try my best to give you the update real time. But yes, we will try to solve it in real time as much as possible, because the same problem might be faced by other people also while doing this the same task. So that will answer multiple people's questions. Most of the time, that is what happens. So yes, I will be flexible, but not infinitely. Cool.
Yeah, for sure. Yeah, but entire this module 7 and entire project, it will take like 30 hours. That's what it says, right?
Minimum, yeah.
Okay.
See, one more thing, like it mentions that somewhere 37 mini projects and 4 major projects.
Hmm.
Can you explain about like what kind of 4 major projects will be accomplishing?
4 major projects. So see, anything you're doing here will be real time. Okay, this is what actually happens in the industry. Like even installation of a Tomcat Apache server, it is not that straightforward. Okay, unlike what I simply used just now, you learned, right, how to install the tree utility. Okay, so this one was a very simple utility, but unlike tree, a Tomcat Apache server installation is application server is not that straightforward. It is not that one-click event. Okay, so that in itself is a mini project. Now,
I meant major project.
Major project, this one I actually answered a couple of minutes back. So major project is this one-liner, building a Java project using Jenkins. Okay, so when you are considering Jenkins, Git, GitHub, Maven, these, so here in module 2, these are the 4 basic softwares that we are going to focus on or use. Like throughout the entire course, Linux always will be there in the background. So I have not mentioned that separately. MobaXterm, Linux, and there will be many other smaller or larger tools that I'm going to use randomly. So that I have not mentioned here separately. That is something that you will get real-time hands-on. Okay, so but when you are able to build an entire Java project manually using Jenkins, that will be your major project for particularly for module 2 only. Okay, because what you are learning here is the focus at the end of the course, rather throughout the entirety of the course, is learning about CI/CD pipelines, continuous integration, continuous deployment. Okay, so initially we have to learn by doing the manual things first, and then we have to ultimately automate it. I don't know if you have joined the first day. I actually showed a very brief demonstration. Like I only made changes in GitHub, and the background color of the website changed. So there were many things which are going on in the background. That is what you will learn. Like that was only like 10% of it. By the time you come to the capstone project, this will be your major thing to learn. Like integrating Kubernetes in a CI/CD pipeline, and which will be completely automated. The only thing, whatever I did in the first day of demonstration, I will be only making the code change. So that is where I am actually doing a role play as a developer. Okay, but we are not developers. We are learning to become DevOps engineers. But then for practicing, obviously, we'll have to change the code somewhere. So you will be doing that pseudo role. So I hope that answers your question. At the end of the course, you should be able to automate this. This is your capstone project. If you can describe this in an interview, like how you did this, yeah, that will give some confidence to the interviewer so that they can hire you.
Yeah. Thank you. Thank you very much.
And
Right.
in the description, it says get 3-year experience. Like I have to go and get 3 years experience.
No. This is equivalent to all these tools, integrations. Because see, whenever you join a company, the larger the company is, the more the more restricted your work will be. And when it becomes restricted, you are going to work in silos. You will only be doing very limited things in a project. You will just be a cog or a small gear wheel in a very large machinery. So that does not give, and in an organization, you will not have so much of access, like having root level access, creating AWS resources, terminating resources. You will not have that much of access. Without access, how will you learn? So what you are going to go through as part of this course is using and implementing installation, termination, configuration, provisioning. All these things are real time. Okay, so that as and when required, you can replicate these things. There are, although this is like just, there will be limited use cases here. Nobody can teach you all the use cases. That is just not possible. Okay, but it should give you a major push, a very solid standing foundation and platform on which then you can start learning on your own. Okay, the final learning you will have to do yourself only. This course is not like, it will not work out if you are only watching the videos. I can assure you, 100% you will fail. You will have to do all the things that I'm doing, each and every command manually yourself, in your own environment, in your own account. So in that sense, it will give you an equivalent amount of experience. But then this is just the starting point. DevOps is like, consider like there are 7 oceans in the world. Now combine all the oceans. But that is what the analogy for DevOps is. It is an ocean of oceans. There are hundreds and hundreds and thousands of tools in DevOps. But then the philosophy, the culture, the usage of the tools, like maybe you tomorrow in a project, like, or where you are applying, they might want, instead of AWS cloud, they might want Azure cloud. The concepts for cloud will still remain the same. When you are using AWS, you will have its own AWS dashboard, like these things. When you log into Microsoft Azure platform, then again, it will be browser based, and then their user interfaces will be different. But the concept of creating a computer virtually in cloud with its own network, with its own subnet, with its own private IP, public IP, these concepts will not change. They will remain the same. It's just that the terminology will be different. To make it a little bit analogous and simpler, you can, people in Japan, people in like in Tokyo, Japan, and in New York, USA, both of them, consider both of them are using the subway to reach from station A to station B. The routes are different, the names are different, the language is different, but the common concept, like there is a train, there are platform, you have to gain access, you have to buy the ticket, purchase the ticket, authorize yourself through the ticket, and then at the exit point, again, authorize that you have exited the station. These concepts are still the same, right? It's something like that. In DevOps, for the same, for obtaining the same objective, accomplishing the same objective, there are multiple tools, but their core concepts will remain the same. I hope that makes sense. I mean, like, beyond this, you will need to actually do the things yourself. Okay, so Manam, you're asking about a discount. This is already a discounted price. Like the original course fees is 16,999. This is already a discount, and on top of that, if you join before 10th, we are already giving you further additional discount there. So that is our last price here. That is we have already provided the maximum discount here. Right, I think I'll have to wrap up now. I have to get into other meetings. So it was nice having you guys join the session. Please join tomorrow also, so that we can continue with our discourse on comprehensive directory listing in Linux.